We're currently holding at T-minus 3 minutes for vertical checks for Bailey on pad 3.
All right, we're live.
Okay.
We're live? Okay. Good morning. My name is Robbie Herrick from the Geophysical Institute, and to my left is Don Hampton, one of the professors at the Geophysical Institute. And good morning. It's 4:05 in the morning here in Fairbanks, Alaska, and we're hopefully minutes away from the launch of the PolarNOx mission. And as we get started, let me get a few disclaimers, thank our sponsors before we get going. So this broadcast is funded through the Heliophysics Education Consortium, which is run out of Goddard Space Flight Center, and we're NASA funded. The Poker Flat Research Range is operated under a contract to NASA's Wallop Flight Facility, and that is part of the Goddard Space Flight Center. This is the first time that we're trying to do a live broadcast from launch, so please, live video broadcast from launch, so please bear with us. If you're looking at the countdown clock, which is over my right shoulder, do not be alarmed. We are not going to launch in 3 minutes. They're in the middle of a test that is counted down to 3 minutes. So maybe you could tell us a little bit about that procedure, Don.
Right. So if you saw the picture of the launcher just a minute ago, now the rocket's actually facing vertical, which is the way we like to launch them. That's always a good thing to do. But when you first put the rocket on that launch structure, you actually do it when it's horizontal. So what we're doing right now is called a vertical test. You go from the horizontal position where you've tested things, and now you've taken that launcher vertical, and now you're retesting all the instruments on board, and that the rocket is talking to the telemetry, that you've got GPS, just all those things you want to make sure that they're still working in preparation for launching a little bit later this morning. So yeah, I just wanted to mention this is day number 8 of the PolarNOx mission. This is our third night for doing a count. First night we had an issue with the rocket, and then last night, if you were watching on here, we had an issue with the launch the structure itself, the electrical problem, but they have fixed that, they've resolved that, and as you see, the launcher is vertical and it looks like we're ready to go. They're going through the count right now. We've halted at 3 minutes. We should probably hear that pick up in a few minutes, and then you'll hear a countdown, but that's a countdown for this vertical check, so don't get alarmed, we're not launching yet. So the window is going to open another 15 or 20 minutes, so we couldn't launch at the moment.
Right. So yes, so the launch window tonight opens at roughly 4:30, which is about 20 minutes from now.
Yeah.
And things are looking good. If you were with us last night, you did not get to see the rocket upright, so things have progressed a lot further along. I noticed before we get into talking a little bit about the mission itself, I noticed as I was coming to the range that there were already a couple of rockets that launched about 30 minutes ago. Can you tell us a little bit about those and what those were?
Right, so those are test rockets. They're about 2 to 3 feet long. They go up to a few kilometers height. The idea there is to test the launch system itself. Basically, there's a clock that counts down, and as that clock goes through 0, it sends out a signal to the launchers to actually ignite the launchers and send the rocket off. And so this is a way to test that system to make sure that all the steps in there are ready to go, but not waste the rocket itself and launch the rocket. That's always a good sign when we're doing test rockets. That means things are looking pretty good. They don't tend to like to waste test rockets if things aren't looking good.
Okay. Do they when they launch the test rockets, are they checking for winds with those in any way, or is that something else they do independent of that?
So the test rockets themselves, I think they can use them a little bit for wind weighting, but not particularly. What they also do is when they launch, they actually we've got tracking radars to actually track where the rocket goes to get a good sense of where it's going to come down and that sort of thing. And so that's a good chance to test the radars to make sure the radars are working as well. Now, but you do bring up a good point. So these rockets we launch are purely ballistic. We don't actually steer them in any particular direction. We can do some attitude control of them as they're flying, but we don't actually try to hit a target. What we do try to hit is somewhere where there's nobody there. And that's a very important thing we do at the range here and at all the NASA sounding rocket ranges, is to make sure the way we fly is very safe. During the evening, you may see in the all-sky camera, when that comes up, you may see a little red dot going up. That's a weather balloon that we send up, and about every 15 minutes or so we send up a weather balloon to look at the winds at different altitudes. Since these rockets go through the lower atmosphere, they can be affected by the winds at lower altitudes and be pushed from side to side. So we need to know what those are. So the NASA brings up this whole team to do this calculation to figure out where all the parts of the rocket are going to go. And if any of those parts land anywhere where there's somebody could be there, then we won't launch the rocket. So it's another safety thing that we put in place.
Okay.
Yeah.
Let's see, maybe we should go through descriptions of the two cameras that we have, and then talk briefly. We have a short clip about the mission itself. So let's flip through the different, the two different cameras.
Right.
And well, right now we're looking at, let's see.
Well, we've switched now to sort of a medium field of view. So that'll be maybe the first or second camera we're going to look at. That will show the rocket going up to about 20-30 degrees elevation, and then we might flip then to this all-sky camera. And so if you can see there, it's actually cleared up a little bit, which is really nice. You can see the stars there, and you can see that this camera looks from horizon to horizon. So when the rocket goes past that first field of view of that first camera, it'll actually go into this one, and we'll be able to see it go off.
Okay.
And it's better. And this one we'll probably start with this one. You can actually see the rocket there. That's that long vertical white structure there in the middle next to that bright building. That's the rocket. We're looking from about 2 miles away up, the telemetry building, and looking down at the hill. Okay. But that rocket underneath that white thing there is about 57 feet long, 58 feet long or so. That white structure you see there is actually a styrofoam box we put around the rocket. As people might not be surprised, it gets cold in Alaska, and so we want to make sure that rocket maintains its temperature. Okay. So we put a white styrofoam box around the rocket, and we actually put in heated air inside there to maintain the temperature of the rocket and the payload, so they're not getting too cold. Because if they get too cold, you can have stress, thermal stresses in there as well.
Okay. And are they saying the cursor? Is that a cursor above?
Oh yeah, the cross up there I think is a cursor from the computer that we've got going as well.
All right, so, all right. I don't know if the live stream sees that or not.
I think what we see on the screen there is the live screen, so they will see that. So ignore that cross up there. That's just a cursor from the computer we're streaming this picture on. So.
All right, and so so we are looking at a box right around the rocket.
That's correct.
Not the rocket itself.
Not the rocket itself,
okay.
yeah.
All right.
There we go. There's the cursor.
Moved the cursor.
The cursor's launched, but the rocket hasn't launched yet, so that's good.
Okay, and all right. Okay, so let's talk about the, perhaps you can give us an intro to a clip that we have about the mission itself, and talk about that, and we haven't mentioned that the PI or anything like that.
Right. So the scientists that came up with the idea for this rocket, we call him the principal investigator, or the PI. It's a shorthand we use, and so you'll probably hear us say that over the night. That's Scott Bailey. He's a professor at Virginia Tech University. He was actually at the University of Alaska for a few years early in his career, and so he's a familiar face around the GI, and so we welcome him back when he comes back. Anyway, he has been very interested in chemistry in sort of what we call the mesosphere, which is a layer of the atmosphere between about 50 and 110 kilometers. It's sort of below what's called the thermosphere, where the temperature increases as you go to higher altitudes. In this region, it's sometimes called the ignorosphere because it's very hard to make measurements there. You either have to send a rocket through there, It's really too low for satellites, and it's kind of too high for balloons. So about the only way you can do it is either remotely by using a camera to look at whatever's going on there. Sometimes you can use radars in that region as well, or send a rocket through it. So in this case, we're using a rocket. What he wants to do is look at the density, altitude profile of the density of this chemical called nitric oxide. And nitric oxide is basically a nitrogen and oxygen bonded together. So NO would be its chemical symbol. And he's using an interesting technique for doing this. He's looking at the spectrum, but it's instead of an emission spectrum like what we see in the aurora where it glows bright, he's looking at the absorption spectrum. So he needs a source of light, a light bulb out there in order to look at that light bulb and see where there's dips in that spectrum. And that light bulb he's using is a specific star, and I can't remember the name of the star, unfortunately offhand. He may actually say it in the clip. But he might describe that in the clip here coming up. So if we could maybe roll that clip and see what it says.
We call the experiment PolarNOx. It stands for polar nitric oxide. When you think of the aurora, people generally think of the glow, and they think of the electric and magnetic fields that cause the glow. But what's less talked about is the fact that all those processes that create the glow also induce some very interesting chemistry that goes on. We've known for quite a while that the aurora creates nitric oxide, and as a student, I was up here making measurements of that. One thing we knew that if it could happen, would be very important, was that if that nitric oxide is created up at the altitudes where the aurora is, if it somehow found its way down to lower altitudes, it would have a big effect on the ozone layer and the chemistry there. And that can have all kinds of ramifications, not just the fact that when you change ozone layer, there's more transmission of ultraviolet light, but the winds will change, the temperature will change. Ozone plays a role in all of that. So mixing nitric oxide and ozone is an important thing. But again, for a long time, we knew that could happen. We didn't know that transport of nitric oxide to the lower atmosphere actually did happen. In recent years, we've seen, not directly, we can't see the NO moving down without special observations, but we saw an effect of after auroral activity, after a season of it, that there was a change in the ozone. And we could see other indirect evidence that it was nitric oxide doing that. But we never observed the nitric oxide itself going down. But we learned that this process in some winters becomes very important. Now there's a reason that winter is important, right? Nitric oxide is being created all the time by the sun. It's also destroyed by the sun. So typically, when nitric oxide is created, it survives about a day. In the polar winter, when the aurora creates nitric oxide, there's no process to destroy it. So it's created and it survives and it builds up to large densities. We've never been able to observe, at least not directly, we've inferred in certain ways, but never been able to observe directly how much nitric oxide is really created in the auroral region, in the polar winter, the long nights. One reason is it's kind of hard to do. You need a dedicated experiment to do that. For different reasons we can talk about, you need a large telescope to make that measurement. So it was something that got put off for a long time, even though we were seeing that the aurora was creating nitric oxide, it was going down to the stratosphere, and it was impacting ozone. It's just been in recent years, primarily because we've gotten so much better at making optics and doing it cheaper, that we've been able now to propose experiments where we can do this and go out and make the observation of nitric oxide in nighttime conditions. So what is the reason? We want to see this nitric oxide. How much is there after a winter of aurora creating nitric oxide? What altitude does it peak? Where is most of this nitric oxide? Can we see evidence of the transport downward? Or can we see evidence what we used to think was happening all the time, where you see a large region build up well above the stratosphere? We just want to see how much is there and where is it in altitude.
Okay.
Okay, and once again, if you're just joining us, my name is Robbie Herrick, and to my left is Don Hampton, and we're here for the launch of the PolarNOx Explorer. And what you're looking at now is a live feed from the pad, and I think we're when it was back on us, you could see we're now at a 12-minute hold on the countdown, so things are looking promising.
Yeah, they just finished the vertical checks. We were talking about that earlier. That's basically checking the rocket is ready to go in its vertical orientation. And they've gone through those, and we're holding at 12 minutes, which is a pretty standard number to hold at. So now we're just waiting for the science team and the operations team to decide when it's ready to go. We've got to go into our window because talking more about safety, one thing we do is we actually communicate with NORAD, which is the U.S. and international group that pays attention to when you launch things in the air, and so we want to make sure they know we're launching things. And we also talk to the FAA, so we have notices into both of them, and we can't really go before we have those notices cleared. But they know about it, and once we get that clearance and are into that time period, we can go when the science team thinks it's ready to go.
Okay.
So this is looking very good.
Yes, and we're, once again, the launch window, it's about 4:20 right now. The launch window will open at about 4:30 and be open for about an hour. So things are looking quite promising.
Right.
Let's see, maybe why don't we talk a little bit about the physical features of the rocket and the payload, and then before we run into our brief next clip that we have.
Yeah, so the like I said, the rocket's about 57 feet long or so. It's a two-stage rocket. The first stage is a Terrier, which is a surplus military rocket, and the second stage is a Black Brant, which is made by a company in Canada. And you saw there earlier there is a picture of the nose cone of that, and that's the payload section, which is the top portion of the rocket. That will separate from the second stage about a minute and a half into the launch. And then there's an attitude control system on there that will point this telescope that you're seeing on the screen right now. They're taking it with the theodolite to check alignment on that telescope. They'll point this telescope directly at a star. Like I said, we need this standard candle or this light bulb, which is going to be this very bright star, and point that very precisely at that star and line it up onto the slit of a spectrograph and be able to measure the spectrum of the light. So that pointing is very fine. It's pretty amazing, and the attitude control system can get very close, but in fact they have to do a special thing. And they use an onboard camera to take a picture of the star in real time, and then they'll have a joystick basically on the ground, and somebody in the telemetry building will be sort of tweaking that to make sure that the star is pointed right at the slit. And I think there's a clip about that by the person who's going to do that, so if we could maybe show that second clip, he'll describe in more detail what he's going to do.
So we chose Algenib as our star because we need to observe ultraviolet light, because that's the light that will be absorbed by the nitric oxide. And it's one of the brighter stars in the UV. But it isn't the brightest. We chose it because we want to observe nitric oxide that's in the polar night. And here in Fairbanks, or Poker Flat, we're not quite above the Arctic Circle, so we're not actually in the polar night. So in the star, when this star is at the right position such that it's such that the atmosphere is between the star and our telescope, which requires the star to be at a certain height in the sky, which is actually below the horizon by about 9 degrees. When the star is at that position, it's north from this vantage point. So that means we get a look deeper into the polar night in order to see the star.
And we're back, and once again, my name is Robbie Herrick, and this is Don Hampton to my left. Watching that, I should have mentioned this earlier. The effort where the part of the mission that tracks the star, that also dictates the launch window tonight, because we need the star. The ability to control where the telescope is looking is limited, and so the star needs to be in a particular place in the night sky, and there's an hour window where they're able to actually look at it.
That's right, and the idea is to look near the horizon, because that way you're looking through the nitric oxide, and as the rocket moves up and down, and as you're looking up and down at the star, you sort of sample different altitudes and be able to come up with what the profile of that nitric oxide looks like. So is it the most dense at 110 kilometers or 75 kilometers, and that's the point of this mission, is to try to determine that. Like I said, it's very hard to do from the ground. It's too high for, well, mostly you can't do much in the way of observing from the ground. There's not an emission line like the oxygen that we see in the aurora that's going to give you that information. And satellites can do it, but they move through fairly quickly, and they don't do it at the time you want them to do it. So that's why we're doing this. So yeah, it's looking good. We've done the vertical checks, and now we're holding it 12 minutes, waiting for the window to open. And there's a picture of the rocket ready to go.
So if we could perhaps get the feeds from the all-sky camera and take a look at that.
Mm-hmm.
Let's see. What's that? The all-sky camera, please.
Mm-hmm. There we go.
So this is kind of an unusual perspective, so
Right.
I thought I'd mention that, so what you're looking at, the center of the screen is straight overhead.
Right.
And I assume this is the same as last night, that south is actually to the top of
That's
this
correct.
view.
That's correct.
So the southern horizon is to the top, the northern horizon on the bottom, and when the rocket launches, this will be the final view that we have as the rocket is going at its reaching its apogee, right?
Well,
at the farthest point.
We won't see it in the apogee. So we can talk about the timing. The motor cuts off well before the apogee. It gives a lot of acceleration, and then it coasts for quite a while.
Okay.
So,
the rocket will probably, in this view, the rocket will come from the right side of the screen?
Actually, the left side in
Left
this
side of the
case,
screen.
yeah. So
Okay.
it's like we're standing and facing north and looking straight up in the sky. And that's kind of why we display them in this direction. If you can see it, you can actually see the Big Dippers in the middle there, and so you get an idea of that's how far north we are here in Alaska, because if you follow those two stars on the left, that actually points to the pole star, which is a little hard to see, but you can see that's almost overhead. That's not
Right.
way down on the northern horizon, which people say in the lower 48 will be able to see. So, yeah.
Okay. And could we go to the other, the medium distance feed?
Yeah, there we
And
go.
so where will the rocket appear in this?
Well, more or less at
Switch to this.
yeah, more or less in the bottom center is where it's going to come through. That green glow there is actually a little bit of aurora. We've been having some aurora all night. It's just cleared up recently. For a while we had some clouds, but it's looking quite good for clear skies. And again, you can see the spots there, which are some stars. It's a little bit noisy in this view, just because the intensity of the aurora is not very bright right now. So we're just seeing a lot sort of random noise in the camera. But yeah, basically the rocket will sort of streak up from mid camera, maybe a little to the left, and sort of aim off to the right. So this is just a little portion of that all sky camera essentially.
Okay.
And then the feed from looking at the rocket itself, that'll be pretty obvious where we'll see the rocket, because you can see it right now. And that rocket will exit that screen pretty fast. That's these rockets are not very gentle. You wouldn't want to be riding on one. The acceleration just in the vertical direction is probably 10 or 12 Gs. Depends on how heavy it is and how well it performs. And then the whole thing also shakes, because the exhaust comes out in sort of a random manner. You get a lot of shaking in the whole rocket. And so there's a lot of just sort of rattling of the whole thing. And you got to be careful that your instrument doesn't have a resonance, or it sort of vibrates at a sort of a sympathetic frequency that matches some of the frequencies in that motion. Otherwise, you get sort of extra motion in that portion, and it might break off, which is not good.
So tell us a little bit about how far up it goes, how rapidly it gets to that distance, when the first stage separates and things.
Right.
So go through the sequence of what we might see after launch.
I'll use my cheat sheet here, because I
Okay.
can't remember all these things. But so the first stage basically burns for about 6 seconds.
Okay.
And the top of that 6 seconds, we'll look here, at the top of that 6 seconds, it's already at, no, I don't have it here. Anyway, it's a few kilometers up there. It coasts for about 20 or 30 seconds, and then the second stage kicks in. Second stage burns for about 20 to 30 seconds after that. So essentially a minute we'll be able to see the light from the rocket. Now once those ignitions go off and it separates from the stage, you won't be able to see the rocket.
Okay.
It won't even get into the sunlight, as far as I know, because we're still looking at that star off to the east.
Okay.
So a lot of people think, oh, we can go out and look at the rocket flying through the air, but you don't get to see that.
Okay. All right.
And then it takes about 300 seconds, a little under 5 minutes, to get to its apogee. And in this case, we're going to about 270 kilometers, about 180 miles or so. And at that point, it reaches its apogee, and then it starts on its way back down.
Okay.
And just like any rocket, once it loses its thrust, it basically is in zero G condition until it hits the atmosphere again. So basically, if you're on the rocket after all that force, all of a sudden everything would go away, and you'd be floating around inside the rocket. Basically, even when it's going up, it's basically falling down, right? So, and then it's scheduled to come down about 600 seconds, so about 10 minutes later.
Okay.
Now this is one of the rockets that we actually deploy a parachute, and we try to bring the payload down kind of gently so it's not broken. That's because you saw the telescope earlier. Building a telescope of that size and that precision that he has is very expensive, and so he would like to be able to use this instrument again in future rocket missions. And so we deploy a parachute a few kilometers up, and then that slows it down and brings it down reasonably gently on the ground. And there will be a team that will fly out the next day after it launches, hopefully that's tomorrow, and go and try to locate the rocket on the ground right away, or the payload on the ground right away. The parachute itself has some bright colors in it, so it usually is really good. Hopefully it doesn't snow. That's a good thing. And then a few days later, once they found where it is, a few days later they'll take a helicopter out there and actually pull it out.
Okay. All right.
And that's a little bit special, is using the parachute to bring it down gently. A lot of the rockets we just let them come down at speed, but we are now have a clean range policy.
Station checks on channel 2, please.
We now have a clean range policy where anything that we send up there, we try and go and retrieve.
Okay.
And if you're in Alaska and happen to be north of Poker Flat and find a piece of a rocket and you bring us the coordinates to that, we'll actually send you a check if we verify it. So you hunters out there, or backpackers, or whoever, if you find a piece of rocket out north in Alaska, send us the coordinates, and if we verify it, we'll send it to you. I believe we've actually just picked up the count. You can see the clock behind Robbie is actually starting to count. I believe this is a real countdown. They're doing station checks right now. Each of the specific payload components, like the structure and the instrument and attitude control and those sorts of things, are checking in and saying yes, they're all ready to go. So looks like we're about 11 minutes away from a launch. So I want to remind people, if you're in Fairbanks, this live feed, there's actually a bit of a delay on the order of 15 to 30 seconds is what we found. So don't wait until 5 seconds before launch, otherwise you might be too late.
That's right.
So go out about a minute beforehand, and you're likely to see the launch then.
Right, and we are located about 25 miles northeast of Fairbanks, and launching towards the north. So if you are in Fairbanks, you should, if you go outside, there's a decent chance you'll be able to see at least the second stage going out. Right?
So and it looks like it's clearing up out there all over the place. So hopefully we got a good view.
So as we count down, perhaps mention a little bit about the layout of Poker Flat. We're hearing we're hearing talk over the intercom here from different buildings, and so where are we, and what are the other buildings?
So we're up on a ridge above where the launchers are, a few hundred feet above the ridge. Here's a picture showing the lower range, and that's a valley, and that's called the Chattanooga River down there, so people in Fairbanks know where that is. We're near the Chattanooga Lodge. That blue building there, the two blue buildings you see sort of in the middle of the picture, are actually where the launcher is. That's a building we put over the launcher when we're building it up, and then you can take a very heavy piece of equipment and pull that building out of the way, and then the launcher's exposed, and then we go vertical like we did earlier this evening. So we're far enough away, we're not in the danger zone, but the people you're hearing on the radio, some of those people are in the blockhouse, and it's hard to show on this picture, but it's basically very close to that building there. And so it's a heavily reinforced building with very thick concrete walls, and it's covered with soil. And they're right down there, so they have direct access by cable to the rockets themselves, so they can talk back and forth to the payload and talk to the rocket itself to make sure things are ready to go. And that's some of the people you're hearing saying, yes, we're ready to go. They say yes or go. So we're about 2 to 2.5 miles away up here on the range. We're in the Science Operations Center, which is the place where most of the science teams will come up and sit in the room we're actually in right now. And typically we're looking for auroral conditions. This mission's a little bit different, and they're not particularly interested in what the aurora is doing. If it was very, very active aurora, they might not launch because that might contaminate their optical signal. So it looks like we're forging ahead here. We're down to about 8 minutes.
So maybe we should, I don't know, what would you like to do here? I think we should maybe you can describe what they're actually talking about over the intercom.
Sure, you're not hearing everything, but we get to hear a little bit more. One thing we do is we're right next to the Steese Highway, which is a 2-lane highway that goes north of Fairbanks. The launcher's about 50 to 100 yards away from that highway. So one thing we also do is send out a couple of roadblocks, and we're hearing a little bit of radio chatter from them. They're listening back to the main controller, Kathy, who's going to be doing the countdown in a few minutes, just confirming that they're in place and that they have not seen any cars go by, because if a car happens to go by, we have to halt the count. We can't launch when a car's there. Same thing on range. If there's somebody driving around on range, we have to stop everything and wait for them to get into a safe place. And there's a zone around the blockhouse down where they are, where you can't be outside. You either have to be in the blockhouse or you have to be outside of that zone. So a lot of safety things go on.
7 minutes.
People who are in Fairbanks see the gate at Poker Flat, the entrance at Poker Flat, and maybe think we're doing secret things in here. No, we're not doing anything secret. We just do things that are kind of dangerous, and so we just don't want people just wandering in, because we're about to send up a very powerful rocket. So things are continuing here. So just to let you know, we're here at Poker Flat Research Range north of Fairbanks, Alaska. We're anticipating imminent launch of the PolarNOx rocket, which is a NASA mission led by the chief scientist and principal investigator Scott Bailey from Virginia Tech. This rocket will launch and go to about 270 kilometers, about 180 miles up, in about 5 minutes. So we're anticipating showing you that launch in a few minutes. If you're in Fairbanks and happen to be up, and luckily it's nice and warm outside,
Right.
If you go outside about a minute before the launch, before that, and look to the north, you should be able to see the streak of light go off there. If you're not lucky enough to live in Alaska, then you get to watch it on this live feed where it's sitting here right now.
And so,
previously checked Y92.
so what?
Check 193, azimuth.
So there's a whole set of checks that they're going through. What are some of these things that they're doing?
Right. So there's a very detailed checklist that they go through. It's not just we go out there and push the button and off it goes. So the idea is that we want to make sure that the instrument's working, because they've spent a lot of money on this. Both NASA and the science team have spent a lot of money putting all this together. So they want to make sure when that time goes by that everything, to the best of their knowledge, is working and is going to go. So what they're looking at is an instrument will have multiple voltages. It might have some temperatures. It might have there's an LED check on that camera that's going to be used to observe the star and point the camera. And so they want to make sure all those things are working, and they have at each interval along here, they will check each one of those things. And so that's kind of the stuff you're hearing sort of in the background. We're not broadcasting all of that here, but you can maybe hear it back in the background here. We're listening to it here on the radio set here. So the team gets very busy when this is going on. Other things we're checking to make sure that the recorders are on for the telemetry. Even though this payload comes down nice and gently, We have to get all the data off in real time. It's not like going out and getting a thumb drive off of that thing and making sure we get the data. So all the data has to come down in real time. So there's a few large antennas up on the top of the hill near where we are, called the telemetry building, that are tracking the radar, or tracking the rocket, excuse me, and pulling down the data. Basically, it's a wireless communication system with a very high gain antenna.
Yeah.
So we're about 4 minutes out. Haven't heard anything to indicate that we're not going to go. So this is looking very good.
Okay, good.
In this case, third time's the charm, right? This is the third time we've counted. We had an issue with the rocket the first time, for those who watched the video but didn't get to hear it, unfortunately. And the second time we had something with the launcher mechanism, had some problems yesterday, but those were resolved today, and looks like we're going.
Okay. All right. I guess maybe we should just leave it on the launch pad here for the last three and a half minutes. And maybe as the checks come up, if you know what they are, you can tell us what they're talking about. I noticed, I heard iridium check earlier. What is that? Right.
So one thing we're doing is, because we want to retrieve this payload, is they now have a system on there that when it lands, they turn on an iridium modem and talk to the iridium satellites, and it gives its position, gives its GPS position, and sends that out over the iridium satellites, and basically phones home to say, hey, I'm here. That should help the recovery team in pinpointing where it goes. The radars that track the rocket all the way through the flight will also give a good sense of where it's going to come down, but they lose it a few kilometers in altitude. They lose it up there, and it can sort of blow, and if there's winds on the ground, it can blow off to the side. So it can be on the order of 100 square kilometers they have to go and search through, and that's a lot of area to lean your head out of an airplane and look at the ground and see where it is.
Right.
So the iridium is a newish system to try to pinpoint where the rocket is on the ground, and that will help speed up the recovery. So there are lots of, like I said, lots of voltages and temperatures on the payload itself to make sure it's working, and also to make sure that the computer that runs the rocket itself is operating correctly.
So what is the acronym RCBs? I've heard that RCB check.
I don't know. I mean,
okay.
So each rocket has its own acronyms. It can be acronym soup, and if you're not a part of that system, you may not know exactly what it is. Okay. RCB may be part of the payload. It may be part of something else. So. Yeah, so at some point here, so about 2 to 3 minutes to where we are now, a lot of things start to happen. So you're hearing some polling from the mission operator, Kathy Rich, down at the blockhouse, asking each of the main payload, each subsystem whether they're ready to go, and they're all answering yes right now. So what happens now at about 2 minutes is things go to internal power, and the umbilicals are basically ready to come off.
Okay, and so we are right at a minute. So if you are local and you want to get outside, accounting for the time lapse on the video feed. So if you're local, you should go outside now to go see the launch.
Right. And we just went through all those sort of 2 minute checks, and everything looks good. So now we're less than a minute away. So you'll see, like I said, you'll see that it'll move pretty fast out of this frame, and then the next frame you'll see it go through for a while, and then we'll watch in the all sky.
All right. Let's let them count down. Last 30 seconds here.
30.
ACS check 221.
20. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, plus 1, 2, 3, 4, 5.
So there you see it in the midfield. There's the first stage is finished.
9, 10.
About 15-20 seconds. There we go. That's probably the separation, and that's the second stage kicking in. And now you're seeing the second stage is sort of illuminating some clouds that have kind of rolled in the interim. But now you're looking in the all-sky camera, and you're seeing basically that rocket is straight overhead. And so by now we're 30 seconds in, 30 seconds in. We're already about 30 to 40 kilometers altitude.
Plus 40.
All right, and so we have liftoff of the PolarNOx mission
Radar tracking.
at
Plus 50.
4:45 a.m. from Poker Flat Research Range.
And we just heard some confirmation that the radar is tracking. That's a good thing. That should also mean, a lot of times what happens is the radar that actually tracks the rocket, we actually slave the telemetry antenna to that. So they're basically pointing in the same direction. So if the radar is tracking, that means that the telemetry antenna will be tracking as well. Now we're going to about a minute. So at this point, we're already on the order of 80 kilometers altitude. So we're already about 60 miles up.
Okay.
Yeah.
DCS is waiting for tracker.
Plus 90.
So a minute and a half into it. And like I said, at this point, after the rockets burn out, there's really not much to see. So if we were down in the telemetry building, we would be watching information come in about that. And pretty soon, I've got the timing here. Some point the Zybion camera comes on. That's about 75. Yeah, so the Zybion camera should have been on by now, and so they should be starting to see images in that Zybion camera, and hopefully it's going to point at the star pretty soon, and they're going to get a nice spectrum of that star.
So
And,
can you tell from the what's coming over the intercom whether they're having success with the science part of the mission?
If we listen pretty closely, we might be able to hear some information. They're pretty busy with what they're doing, unless they have a specific thing in the checklist that says that they have to say this or that. A lot of times they will be pretty quiet about it because they're really concentrating pretty hard on making sure everything comes in and they don't miss a specific step. So yeah, this is great. This is our first launch for 2017 here at Poker Flat. Everything looks so far looks good. At least the first and second stage look quite good as they went through. We've just heard that the telemetry is tracking. The radar is tracking, and I think I heard in there that the telemetry was also being received, and that's very good. That's a very good sign. That's a good sign that the data that will come down will be
Plus
good.
3 minutes.
So now we're 3 minutes into the launch, and that gives we're getting almost up to our peak altitude, our apogee. We're already about 150 kilometers up, so about 90 miles up or so. So, like I said, these rockets, once they go, they start moving pretty fast. As you saw, it moved through that second camera pretty darn fast.
Yes.
And like I said, that result or that corresponds to a very large acceleration. So, you wouldn't want to be riding one of these rockets. It wouldn't be much fun.
And it has rapidly saturated our first camera.
Oh yeah, that's right. It's quite a bright. It lights up the whole valley. We'll be able to look at some of the other cameras. And we've got some people out taking still photography and also some other videos as well. So later on we'll put together a sort of a edited film of this as well, and you'll be able to see some of those versions as well. Yeah, but the whole valley just sort of lights up because that's a pretty powerful motor that goes off to lift all that weight. I read somewhere that this payload is about 1,000 pounds.
Okay.
You were asking about that yesterday. This payload is about 1,000 pounds, and that's a pretty typical weight. There's some that are a lot lighter, but this one's sort of a typical one for an instrumented payload. So 1,000 pounds, and then the rockets themselves weigh several thousand pounds. So several tons of material just left the Earth's atmosphere and went into space, and will come down somewhere in the middle of Alaska.
And I guess last night we had a few questions about the overall cost of the instruments and the rockets.
Yeah. So there's sort of two budgets that go in these things. One is the science team has their own specific budget, and that's the money to build the instrument and do whatever calculations and the analysis after they get the data back to make all that happen. And that can range quite a bit, but it's on the order of about $1 million for one of these rockets. And then the other part is the rockets themselves and the computer that runs the rocket. Wallops takes care of that, and so they've got an engineering team that operates that on there, and that's just part of their overall budget. They do so many rockets a year, and I don't know what that number is offhand. But $1 million sounds like a lot of money, but if you think about it, if you launch a satellite a fairly cheap satellite now for NASA is on the order of $200 to $300 million. So this is a very small drop in the bucket compared to what will happen for a satellite.
And what happens with the data? So with like all NASA missions, the data will eventually be public, correct?
Yeah, that's correct. The data will be stored at some server that will make it public. Some NASA missions, the PI gets first crack at it. So for a few months, they may have unique access to that before it goes public. But no, we always have something in our proposals where we have to basically say the data will be available to anybody who wants to use it and to do their own analysis of the mission themselves. And that's a hallmark of science, is being able to share and verify the data.
So we are at
about 6 minutes,
6 minutes, T plus 6 minutes.
Yep.
So will we get notification when do we know when the thing touches down, and will we get notification of that?
What we'll do is like I said, there's a couple of radars that are tracking the rocket or the payload at this point. They will track that until they can't, and when they can't track it, they will what they usually say is splash, and that's sort of a holdover from when we used to launch from Cape Canaveral in Florida. When it came down, it usually splashed in the ocean. They may or may not say splash, but they will say either loss of signal, or they may say splash, which means they've lost contact with the payload. That may not be it's down. It may not mean it's down yet. That means it's just gone below the horizon and they can't track it anymore. But very soon after that, it should be down. Yeah. So we're about 7 minutes into it. We're expecting that confirmation about 10 minutes or so. The chute should deploy a little after 10 minutes, about 10 minutes and 30 seconds. So we're about 3 minutes away from that. They should still be doing their mission right now. About 450 or 500 seconds into the mission, they'll probably turn off the cameras. There's some high voltages in the cameras. That's an interesting thing too. Is it's hard to test these cameras all the way because there's some high voltages, and if you turn them on, we just got confirmation the shutter door is closed, so they're actually shutting down the optical instrument and they're turning off the high voltages. And the reason they turn off the high voltages is because if you turn the high voltages on in the air down here where we live, you would actually get arcs across that and might burn out the power supply that supplies those voltages. So they really can't turn on those high voltages until they get to altitude. Okay. So sometimes that's a little bit of a nail biter to know whether those high voltages are going to work correctly. Now they can test them in vacuum chambers here on the ground if you've got a special chamber where you can evacuate that and simulate like what it is when they are flying at those altitudes. Then you can turn those on there and confirm that that power supply is working. But part of the pre-launch checks, you can't do that because there's a risk of actually shorting out those power supplies.
So there's two things that are going to come. So the first stage presumably has already landed somewhere.
Yeah.
Okay.
Yeah, it basically lands across the highway over on some university property.
Okay, all right. And it's easy to find because it's a very short arc that it takes, so so they don't need any tracking equipment on it.
That's correct. That's right.
Yeah. And then the second stage remains connected to the instrument? Is that
actually,
correct?
I believe this one separates, and so the second stage will come down north of the White Mountains here.
Okay.
And there's one of the radars is actually tracking that stage, and we'll track it down to where it comes down, and the recovery team will also go look for that. That one will be delayed. They won't do it right away. They'll probably actually wait until the summer to go and do that, to track that one down. But because the investigator wants this payload back, they will actually catch a plane tomorrow, or actually charter a plane tomorrow, and go fly the grid around where they expect that payload to come down, and try to catch a glimpse of the payload itself, or maybe the parachute, which has some bright colors in it. We should be able to see. So we should be getting pretty close to hearing confirmation from the tracking radar that maybe they've lost signal. So we might listen for that.
10 minutes.
So we're 10 minutes. We were expecting about 10 and a half minutes for that maybe to happen.
Roadblocks 1 and 2 coming back.
1 copies.
We're also pulling back the roadblocks since we're clear now.
All right, and the sky is cleared up some too.
Yeah, it's very nice. It was very much cloudier earlier. So I'm not hearing that, but we expect pretty soon to hear some sort of confirmation that they've lost signal with the tracking radars and then it's down. Like I said, with this new Iridium system, especially on this parachute, the one with the parachute system, we should also maybe get essentially a phone call from the rocket saying, hey, I'm on the ground and this is basically where I am. And that should also help the recovery team go and do that. So it looks like a successful mission. We heard some confirmation from some of the team that some of the components on the payload had worked. There's nothing really over the intercom that we heard that said whether they were pointed directly at the star, but we certainly hope that's the case because that will make a nice successful launch. So we're 11 minutes into it. We probably expect that the payload is now down on the ground or floating down close to the ground and coming down nice and gently. So it looks like a nice successful launch. That was great to see the first launch of 2017 from Poker Flat Research Range.
And this is our first successful video broadcast of one of these launches, and we're very excited about that.
Right.
If you're watching now, we will post the entire feed of this video on the YouTube channel for Poker Flat. So if you want to re-look at the launch again.
Yeah.
And our plan is to also produce take some of the footage and some of the introductory clips and things like that and make kind of a mini documentary that'll be a little flashier regarding the launch, and that I believe will also be posted, available through the Geophysical Institute website and the Poker Flat website and YouTube channels. So look for that sometime in the coming weeks. And before we sign off, maybe we should mention what's coming up in the next month or so for Poker Flats.
Right. So this is the first of 5 launches we hope to do this year. We've got 2 more teams who are actually on range already, starting to put together their payloads, and the rockets are going as well. So we have Robert Pfaff from Goddard Space Flight Center is. Okay, so they're talking. It sounds like they've finished the launch there. So Robert Pfaff will be up. He's got 2 rockets he's going to launch in the same night. One will be an instrumented rocket to look at some of the particles coming down to create the aurora, and the other one will be basically a chemical tracer that they leave behind. And as they watch that chemical tracer move around in the upper atmosphere, they can get the sense of what the winds are at those altitudes. And those altitudes are very hard to measure the winds. And the idea there is to look at how the aurora affects the winds at about 150 or between about 100 and 150 kilometers. And then Christina Lynch from Dartmouth College also has 2 rockets. Those rockets will actually go on 2 different nights. We're looking at 2 different auroral conditions and looking at basically how fine structure in the aurora is important for affecting the upper atmosphere and affecting its interaction with the magnetic field and what we call the magnetosphere, which is sort of this large bubble of plasma that surrounds the Earth. So we're expecting those. The first of those we're expecting to count on February 14th, UT. That will be the night of the 13th here in Alaska. But on the 14th Universal Time, we expect to do the first count of those. And there'll be a window for those on the order of about 2.5 weeks long. That's when the moon is down. It'll be a little tougher to say exactly when those rockets are going to launch, because in these cases we have to have specific auroral conditions.
Okay.
So kind of what we saw tonight is we held it for 12 minutes for a while, and then off we went because we had the window open, and this principal investigator didn't really care what the aurora was doing. The ones in February were going to be more interested in the aurora. So we'll basically hold it 10 minutes or 12 minutes for a long time until the aurora decides to come out and play. And when the aurora decides to come out and play in the right way, we'll launch the rocket and see what we see. So,
all right.
So something to look forward to, and we're hoping to do very similar to what we're doing right now for those rockets as well, although I think we'll have a couple of different faces here doing the live stream. because I'm actually involved in a couple of those rockets. I'm going to have to be busy doing those as well.
Actual scientific things. Or
well, yeah, we hope so.
talking on it. All right. Do we have any final announcements, or what do you think? Are we ready to sign off?
I think that's it. I'm just very pleased to see the first rocket of 2017 go off, and it looks like at first blush it sounds like things went well.
Okay, all right. And so once again, I'm Robbie Herrick. This is Don Hampton, and we thank you for joining us for the first launch of the season out here at Poker Flat Research Range. And with that, I guess we'll go ahead and sign off.
Yep.
Have a good morning.
15 minutes.